Welcome to this tutorial on Cloud Build, Google Cloud Platform's powerful continuous integration and continuous deployment service. Cloud Build is part of our GCP DevOps series, where we explore essential tools that help automate and streamline software development workflows. In this video, we'll introduce you to Cloud Build and understand how it transforms the way applications are built, tested, and deployed on Google Cloud. Cloud Build is a fully managed serverless platform that executes your builds on Google Cloud infrastructure. Think of it as a service that takes your source code and automatically transforms it into deployable applications without you needing to manage any servers or build machines. The platform is serverless and scalable, meaning it automatically adjusts resources based on your needs. It enables automated workflows that handle repetitive tasks like building, testing, and deploying code. And it provides fast deployments, helping teams ship software updates quickly and reliably. Cloud Build comes with several powerful features that make continuous integration easy. First, build configuration allows you to define your entire build process using YAML or JSON files, giving you full control over each step. Second, source integration lets you connect Cloud Build directly to popular repositories like GitHub, Bitbucket, and cloud source repositories, so builds can start automatically when code changes. Third, custom build steps enable you to use pre-built Docker containers provided by Google or create your own custom containers for specialized tasks. Finally, artifact management ensures your build outputs, whether they're Docker images or application packages, are securely stored in cloud storage or artifact registry for later deployment. The heart of Cloud Build is the configuration file called cloudbuild.yaml. This file defines exactly what steps your build should execute and in what order. Let's look at a simple example. The Steps section contains a list of build steps. Each step specifies a name, which is the Docker image to use as the builder, and args, which are the arguments passed to that builder. In this example, the first step uses the Docker builder to build a container image, and the second step pushes that image to Google Container Registry. The Images section at the bottom tells Cloud Build which container images should be stored after the build completes. Variables like project ID are automatically substituted with your actual project identifier. Understanding build steps is crucial for working with Cloud Build. Each step has three key components. First is the name field, which specifies the builder image. This is a Docker container that contains the tools needed to execute your task, like the Docker command line tool or Maven for Java builds. Second is the args field, which contains the arguments or commands passed to the builder container. These are the actual instructions that get executed. Third, Cloud Build executes all steps sequentially, meaning each step runs one after another in the order they're listed. This ensures dependencies between steps are respected and your build process follows a logical flow. Build triggers are what make Cloud Build truly automated. They allow you to automatically start builds when specific code changes occur, eliminating the need for manual intervention. Branch push triggers start a build whenever code is pushed to specific branches in your repository, perfect for continuous integration workflows. Tag push triggers activate when you create new tags, which is commonly used for release builds. Pull request triggers run builds when pull requests are opened or updated, helping you catch issues before code is merged into the main branch. And finally, manual and scheduled triggers give you the flexibility to start builds on demand or run them on a schedule using cron expressions, useful for nightly builds or periodic tasks. Let's walk through a typical Cloud Build workflow to see how everything connects. It starts with a code commit, where a developer pushes changes to a source code repository like GitHub. This automatically triggers a build based on the trigger configuration you've set up, whether it's a branch push or pull request. Cloud Build then executes the build steps defined in your cloudbuild.yaml file, running tasks like compiling code, running tests, and building container images. Finally, the build artifacts are either stored in cloud storage or artifact registry, or deployed directly to services like Cloud Run, Google Kubernetes Engine, or App Engine. This entire process happens automatically, enabling continuous delivery of software updates. Cloud Build excels in several common DevOps scenarios. Container builds are one of the most popular use cases, where Cloud Build compiles your application code, packages it into Docker images, and pushes those images to container registries for deployment. Automated testing is another key use case, where unit tests, integration tests, and other quality checks run automatically on every code commit, ensuring bugs are caught early. Application deployments leverage Cloud Build to deploy applications to various Google Cloud services like Google Kubernetes Engine, Cloud Run, and App Engine, creating end-to-end continuous delivery pipelines. And security scanning can be integrated into your build pipeline, running vulnerability scans on container images or dependency checks to identify security issues before they reach production. Cloud Build offers significant advantages for development teams. There's no infrastructure to manage since it's fully serverless. You don't need to provision, configure, or maintain build servers. Everything is handled by Google Cloud. Auto-scaling means the platform automatically scales based on your build workload. Whether you're running one build or hundreds of parallel builds, Cloud Build adjusts resources accordingly. Integrated security is built in, with support for IAM roles and permissions, encrypted builds, and compliance with security best practices. Pay-per-use pricing means you only pay for the build minutes you actually consume, with no upfront costs or long-term commitments. Being GCP native, Cloud Build integrates seamlessly with other Google Cloud services like Cloud Source repositories, Artifact Registry, and deployment targets. And fast execution is enabled through features like parallel builds and caching support, which speed up your build times significantly. These benefits make Cloud Build an excellent choice for teams looking to implement modern continuous integration and deployment practices on Google Cloud.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.